You want to know how crossplane compositions work? You're in the right place. Today, I will compare crossplane compositions and Terraform modules and showcase the implementation of a Google Kubernetes Engine cluster in both technologies. If you're new to crossplane, please check out my introduction to crossplane video. I put the link in the description, and also you can find it somewhere at the top of this video. Let's dive right in. Alright, on the right side we have the playbook for today's demo. I will put the link in the description. You can check it out later if you want. And on the left side we have a repository with all the YAML files and, let's say, Terraform code that we want to talk about today for the sake of our demo. This is the repository. You can clone it, check it out, and basically redo whatever I do at your own pace at home if you like. So we discussed Crossplane in our introduction to Crossplane video. It's an advanced tool for managing public cloud infrastructure using the Kubernetes API. It extends the Kubernetes API and allows you to define Kubernetes resources, and then Crossplane pods and providers will look at your resources and call the external API of the public cloud providers to provision those cloud resources for you. Just like Terraform, you as a platform engineer would like to probably bundle those resources together and create a module and hide some of the complexity of your infrastructure implementation from your consumers, from the application developers that you are serving. So Crossplane does that by providing a simple claim API for the application developers, and then you as a platform engineer need to create a composition. That composition will serve as a backend to that claim API. We're gonna have a look at that and demystify what I just talked about. But before we do that, there's a very useful diagram in here we can have a look at. This diagram, we have the application team territory or area and the platform team. So the application team, all they want to know about the infrastructure is that they want to claim a piece of infrastructure, whatever we define and whatever basically fits our organization needs. So we say, if you want to define a cluster, you don't have to worry about if it's a cluster on-prem or on Azure or AWS or Google Cloud. Just create a claim object and configure this claim object as you want, and I will take that claim object and map it to my Crossplane implementations. So we, as the platform team or people on the right side, need to implement the claim API. And how do we do that? By creating a composite resource definition object. As a composite resource definition is a CRD or a custom resource definition added to the cluster once we install Crossplane. And ideally, when the application team create a claim in their own namespace, Crossplane will map that namespace scoped object or resource to a cluster scoped resource, which is called composite resource. And the actual implementation of the backend of the claim API is the composition. So the composition defines what exact components or managed resources need to be put together to have that piece of infrastructure ready and up and running. So in case of a Google Kubernetes Engine cluster, you can think of the cluster object, the node pools, or maybe we want to have the cluster production ready, so we want to add namespaces or install Helm charts and so on and so forth. All of that will go into compositions. Once Crossplane has this four building blocks, it will go ahead and provision the infrastructure for us, and we'll start creating some managed resources for us. So let's now have a look at the code. Before we go through the playbook, I would like to first have a look at a Terraform module for implementing a Google Kubernetes Engine cluster. If you know Terraform, Terraform uses modules, and you can define all the resources you want in the module itself. In our example, this module, our GKE cluster module, is using another module. But you can have as many resources as you want in a module implementation. Like maybe in case of a GKE cluster, you can have Helm charts and or define use the Kubernetes provider to define your namespaces and so on. But in the end, what you make configurable for the user of your module is the input variables to your module. You can let them, let's say, specify the project ID, the region of the cluster, the name, so on and so forth. And as we can see, like the way our module is being consumed, we have, in the root of our Terraform code, we are referring to it and we're providing some values for the variables of the module. And some stuff are coming from the Terraform variables itself, and some stuff are hard coded as a value. Now let's have a look at Crossplane implementation of resource bundling. So for having Crossplane, first we need to have an operation cluster. In the Cloud Shell environment, I have access to Minikube, so I'm just gonna simply go ahead and use Minikube. I have MK alias for Minikube. I'm just gonna do MK start to start my Kubernetes cluster. Okay, now my Kubernetes cluster is up and running. So if I do MK status, I see my control plane, my Minikube cluster, which acts as a control plane in my example, is up and running. So next we need to install Crossplane. Let's do that. And so now Crossplane is installed. If I do kget ns, I see Crossplane namespace in here, which is good. Now we need to create the GCP credential secret for Crossplane. We need to have a service account. The service account needs to have enough permissions to, let's say, provision resources, provision our composite resource for us. We are simply using a role admin, and then we need a key to that service account, and we create a secret out of that key into the Crossplane namespace. So I already have the key in here, GCP creds. I'm gonna simply run this command to create the secret in my Crossplane namespace. Next, if you haven't done already, you need to clone this repository to have access to these YAML files. Next thing, we need to apply these dependencies.yaml to install a bunch of providers and functions and so on. We're gonna get to the functions in a later video, but for now, we're just simply going to apply these dependencies. A bunch of Crossplane resources are gonna be installed. So once we have all this stuff applied, we should run the package revision and keep watching it and wait until everything has the status of healthy and is ready for use. Alright, it took almost like 4 or 5 minutes for the Crossplane pods and providers to reach the healthiest status, and all the dependencies are now installed. So I'm going to exit out of this command. So now we need to configure our GCP provider with the secret we created in the previous step, the key of our service account that we installed into the Crossplane namespace, the GCP credentials. So I'm just going to simply run this command. Okay, now the provider configuration is there. So next thing, we need to apply our composite resource definition, or XRD. On the left side, you can have a look at the YAML file for that. As you see, it is using the Crossplane type of composite resource definition. You can use whatever name you want for it, but Crossplane recommends using a fully qualified name for that. So if your organization is called example, it would be ideal if you just use the name of your composite resource and your the fully qualified name of your organization, example.org, and you can set some labels if you want. And what is important is that you're defining an API. You're defining an API for your claims and for your composite resources. So for an API, for a Kubernetes API, you need to have a group. You need to have the names for your composite resources and for your claims. So this is what your application team will see and will consume. And you need to define your version. So if you make some changes to your API schema in the future, you want to bump up this version from alpha 1 to beta or alpha 2 or so on and so forth. And the most important part of this XRD is this Open API v3 schema. This is how you define the parameters that are configurable from your application team. They can simply change these values in their claims, and they have what they want. So for example, in our case, we can let them specify the version of the Kubernetes cluster, the type of the nodes, let's say small, medium, large, the minimum number of nodes. So when the cluster is not running a lot of workloads, it can scale down to a minimum number, and that minimum number in our case is 1 by default. And if the application team wants to have a bunch of namespaces be created after the cluster is provisioned, they can provide an array of parameters in the namespaces argument and have their namespaces in the cluster after it's provisioned. So this block is the most important block in this file. And if you scroll down, there are some other blocks that define, let's say, how the status of the composite resource is defined. And when we do get, let's say, claims or composite resources, what columns do we want to show up? So let's apply this one. It's now created. And now we need to create a composition. So before I open up this composition file, let's look at a deprecated, more simpler version of composition, which was the way compositions were defined almost 3 years ago when Crossplane was at earlier stages. As you see, the way they implemented their composition API, that they just wanted to have a bunch of resources, an array of resources that you could simply define, similar to Terraform, and you could say, I need a cluster, I need node pool, and you configure the stuff as you want, and the rest of the stuff are coming from the parameters you specify in your claim API, and what is configurable you also define in the XRD. So that's how a simpler version of composition looks like. But we are not going to use that. We're going to use a more modern version of it, which is called using composition functions. So what was wrong with the old version? There were a bunch of complaints from the community, from the engineers, developers, that there's too much YAML to write, and the structure of the YAML is inflexible. So when we define your resources statically like that, there is no way for us to configure things like conditionals or loops and so on, and you need to write a lot of YAML, and sometimes you need to repeat yourself. The way the Crossplane team answered this request, that they said, like, we are not gonna build another Helm, let's say, templating language for looping and conditionals and so on. Instead, we provide you a framework or an SDK so that you can create your own functions written in Go or Python to provision your infrastructure. Your functions need to have an input. The input to your function can be resources, just like we had in the old version. But when your function returns, it needs to write those resources to the desired state. So when we define a pipeline, when the first step of the pipeline calls this function and this function returns, the output of this function needs to pass into the next step of the pipeline. And this way, it is super flexible. We can code our infrastructure provisioning logic as we want. And the functions API is currently at the beta stage, and this is going to be the way Crossplane compositions are going to be defined and written from now on. So now let's apply this. And now we have the composition. So if I do get composition, I have my cluster Google. So now we have done all the setup and everything is ready for our application team to create a claim. And ideally they do it in their own namespace. So we create a namespace for them, and they can just simply go ahead and create a claim. Before applying it, let's have a look at the claim. It is using the API we created using the XRD, example.org v1 alpha 1. They are going to claim a cluster, and they can specify a name. And importantly, they can select the composition they want. So if we have multiple composition in our Crossplane implementation, they can choose whether they want their cluster to be on Google Cloud or AWS or Azure or any other external provider that we have implemented a composition for. And they can also specify the parameters. So in this example, our application team wants a Kubernetes cluster with medium size nodes, and the minimum number of nodes for the cluster should be 1. So now let's apply this. And now to verify the resources, we can simply run this command, see if our claim is created. It shows that it is created, it is being synced, it's not ready yet. So, and if I run this command to see how this claim in the namespace of a team is being mapped to a composite resource, we see in the events we have a bunch of messages that the cluster is not yet ready, but it is being created. So if I look at my Google Cloud dashboard, I see my A-team GKE cluster is being created, and I need to just give it some time, maybe a couple of minutes, until it is ready. So I'm just gonna pause the video for now. All right, so now provisioning of my Kubernetes cluster is complete. So if I now go back to my playbook and run this command to see the clusters and node pools of my cluster, I see one cluster resource is ready and one node pool resource. And even if I do get managed to see all the managed resources and provisioned resources by Crossplane, I see I have the cluster, the node pool, the Helm chart I installed using the composition function, the Helm chart for Cilium, and the 2 namespaces, the dev and production namespaces, to make the cluster really up and running and made ready for production. And if I want to access this cluster, I can run this command to get the kubeconfig of the brand new cluster. So instead of now if I do current context, I see I'm pointing to my operations cluster, to my Minikube cluster. Now I want to interact with my just created cluster. So if I run this command, I should be able to get a new kubeconfig.yaml, and then if I set this environment variable to this kubeconfig.yaml, I should be able to talk to the Kubernetes API of this cluster. So let's do that. So now I have the kubeconfig, and if I run this, and now I can run kubectl get nodes to get the nodes of my brand new cluster, GKE A-team. Even also the namespaces and everything is now working. Dev and production namespaces are already there. For destroying the infrastructure, destroying the cluster, we can simply run these commands. First, we unset the kube config to point to the minikube cluster again, our operations cluster, and on our operations cluster, we delete the A-team GKE resource. So now, if I look at the GCP dashboard, I should be able to see that the cluster is being destroyed. That's it for this demo. I hope you liked it. If you did, please give it a like and subscribe to the IDP playlist. And also, if you want to have a video on how to write a composition function, please let me know in this comment section. Thank you.